In this lecture, we will mainly discuss the practice questions and its solution, which already given in lecture 11. Okay. Again, mainly the property used in this particular problem is the multiplication by n or the differentiation is a domain. So very important property. Now we'll see how to solve this particular question. Here you can see that y of n is equal to 1 by 2 into n square plus n into 1 by 3 the whole raised to n minus 1 into u of n minus 1. So in order to solve this particular problem, we need to use many properties in an easy way. So first I will rewrite this particular equation. Then you can write y of n is equal to, I can split this, so I can write like this: 1 by 2 n square 1 by 3 the whole raised to n minus 1 u of n minus 1 plus 1 by 2 n 1 by 3 the whole raised to n minus 1 into u of n minus 1. Okay, now we can see that here there are two signals. One is like this and another signal is the second part. So here we need to apply the linearity property. If we know the transform of two signals x1 and x2, we can find the combination by simply adding, provided there is an overlapping ROC. Okay, so in this case again you can see that this is n square and here it is n into, so we need to use the differentiation property. Okay, we need to use this differentiation property. Now we can see that there is u of n minus 1 and n minus 1, means you can see that this is actually indicating the time shifting property. Okay, so we need to use the time shifting property, linearity property, and the differentiation property. So before doing the entire signal, first we will take the one part. Okay, which I will write. For example, I can take let it y1 of n. Okay, it's 1 by 3 the whole raised to n into u of n. Let I can assume that there is one signal y1 of n which is 1 by 3 the whole raised to u of n, and it follows the standard form and is something like a raised to n into u of n. Okay, and whose transform can be written as z by z minus a, and ROC can be written as modulus of z greater than a. Okay, based on this you can write it becomes z by z minus 1 by 3, and the ROC you can write its modulus of z greater than 1 by 3. So we got one signal. Now we can see that this signal is actually a shifted version of the first signal. Okay, now we can write let y2 of n. Okay, and assume that this is actually y1 of z. Now we can write y2 of n, which is a shifted version of y1, that is y1 of n minus 1, means you can write this signal. Okay, now n minus 1, so it becomes 1 by 3 the whole raised to n minus 1 into u of n minus 1, and the Z transform of this particular signal I can write by using the Z transform property. Okay, this is a time shifting property. So now we need to apply the time shifting property here. So we need to apply the time shifting property. Okay, this is already given. So by applying the time shifting property, we can say that if you know y1, so you can write z raised to minus 1 y1 of z. So that's a transform. So y1 is already given, so we can write z raised to minus 1 into z by z minus 1 by 3. Okay, and now we can see that these two terms are cancel and these two terms cancel, and the answer becomes 1 by z minus 1 by 3, and here you can see the ROC will be same. Okay, modulus of z greater than 1 by 3, because there is no importance for z raised to minus 1, it will cancel with the numerator. So this is actually y2 of z. Okay, y2 of z. Now we got the z transform of this much portion. Okay, now we can see that which is multiplied by n. Okay, now we can write the third signal. Let's y3 of n is equal to n into y2 of n. Okay, and or we can write n into 1 by 3 the whole raised to n minus 1 into u of n minus 1. And now we need to apply the differentiation property. Okay, now we need to apply the differentiation property, differentiation in z. Okay, based on that property you can write, because there is n into, okay, n into something, so we need to apply differentiation property. So we can write minus z d by dz. Okay, and this much portion is known as y2, and the transform is y2 of z, so we can write y2 of z. Okay, and after rearranging this you will get minus z d by dz. y2 of z is 1 by z minus 1 by 3, and we can write like this. It becomes minus z into minus 1 by z minus 1 by 3 the whole square. Okay, and ROC will be same, that modulus of z greater than 1 by 3, because there is no change in ROC if you apply differentiation property. So now we got y3 of z. Okay, so one part is over, so this much portion we got, actually this much portion we got, and simply you can multiply by 1 by 2, and here if you look at this particular equation, already it is n into 1 by 3 all raised to n minus 1 into u of n minus 1 is already given, and now we need to multiply again with a n. So I can write the next signal, that is y4 of n. y4 of n is equal to n into y3 of n, means I can write n into 1 by 3 the whole raised to n minus 1 into u of n minus 1. Okay, and there is a transform. Now again we need to apply the differentiation property, because again it is n into, so I can write like this, minus z d by dz, and this much portion is y3, so we need to apply this transform of that part, that is y3 of z. Okay, and if you find the transform, minus z d by dz, in the previous case it's simply z by z minus 1 by 3 the whole square. Okay, now we need to differentiate this portion, and if you differentiate this you will get minus z into z minus 1 by 3 the whole square into derivative of the numerator is 1 minus z into 2 z minus 1 by 3. Okay, as a numerator, and the denominator you will get z minus 1 by 3 the all raised to 4. Now we can take this term as a common. Okay, here also this term, so I can write it becomes minus z into z minus 1 by 3. Okay, and remaining z minus 1 by 3 minus 2z, and denominator it becomes z minus 1 by 3 the whole raised to 4. Now we can cancel these two terms and becomes 3, and the final answer will be like this. Okay, z by z plus 1 by 3 divided by z minus 1 by 3 the whole cube, and the ROC will be same, modulus of z greater than 1 by 3. Now I will write the final equation, final answer. Sorry. So the final answer I can write like this. The transform of x of z can be written as 1 by 2 into y4 of z. Okay, y4 is this is y4 of z. Okay, y4 of z plus 1 by 2 y3 of z. So if you combine all this, you will get 1 by 2 as a common, then remaining you can write z into z plus 1 by 3 divided by z minus 1 by 3 the whole cube plus z by z minus 1 by 4 the whole square, which is equal to z square by z minus 1 by 3 the whole cube. Okay, after simplification I can write like this because both the signal, for this signal ROC is modulus of z greater than 1 by 3, and for this signal also more as 1 by 3. So that's why I can apply linearity property. Okay, linearity property, and the final ROC you can plot this is a real axis, this is imaginary, and this is z plane, and this is a point 1 by 3. I can draw a circle at 1 by 3, and it is greater than 1 by 3. So both signal converge modulus ROC. So this is ROC. This is another interesting question. It's very important. In this question, it's not multiplied by n; it's multiplied by 1 by n. So you need to take care of this kind of question. It's very important question. And again we need to apply the differentiation property here, but we will do in a different way. So let assume that we are defining a new signal which is y of n, which is equal to sorry, y of n is already given, so now we need to define x of n. Okay, so x of n is equal to n into y of n. Okay, assume that there is a new signal x of n, and which is equal to n into y of n, and means you will get the new signal like this, minus 2 the whole raised to minus n into u of minus n minus 1, and here also this is not in the standard form, so I will rewrite this particular portion, which is actually 1 by minus 2 the whole raised to n. Okay, u of minus n minus 1. Now you will get this as a standard form. For example, it's a raised to n into u of minus n minus 1 and also minus also. So this is a standard anti-causal signal, so you can write the result like this: z by z minus a and the modulus of z less than a, because it's an anti-causal signal. Okay, now we can compare this particular signal. So we can write this signal is x of n, so x of n can be written as 1 by 2 the whole raised to n u of minus n minus 1 can be written as z by z minus 1 by minus 2, so it becomes plus. And you can see that in the standard form there is a minus sign, but there is no minus here, so it becomes minus. And the modulus of z less than 1 by 2. Okay, you can write like this. And now you can see that here the x of n, so okay, x of n is defined as n into y of n. Now I can take the property, differentiation property here. So n into x of n, n into x of n can be written as minus z into d by dz of x of z. So based on that I can write, if you take this particular signal x of n into n into y of n, okay, I can take the transform here. I can take the z transform of this particular equation, okay, this particular equation, then I will get it becomes x of z, okay, is equal to here we need to apply differentiation property, so I can write minus z d by dz of y of z, okay. And here we got y of x of n, so we know x of n. Now we need to find the transform of the signal. That is already we got that this is x of z, okay. Now I can substitute here this quantity, so I can substitute x of z here, so I can x of z here, so x of z is minus z divided by z plus 1 by 2 is equal to minus z d by dz of y of z, okay. And I can simply substitute this x of z. Now we can see that both side there is a minus z, so I can cancel this. So remaining I can write, remaining portion I can write like this, is 1 by z plus 1 by 2, which is equal to d by dz of y of z, okay. In the question we need to find the transform of y of z, okay. We need to find the transform of y of n, which is y of z. So I need to find the solution of this particular, I need to find the solution of this differential equation, okay. So I can use a method, I can cross multiply this, so I can write 1 by z plus 1 by 2 dz, okay, into dy z, okay, and I can integrate both sides, so it becomes simply y of z, okay, and this becomes log z plus 1 by 2, okay. And here you can see that the ROC is same, because when you apply the property, differentiation property, there is no change. So this is 1 by 2, the point 1 by 2, and less than 1 by 2 means inside the circle. So this is the ROC. So very important question, you need to remember this. When there is minus 1 by n, the answer will be in log form, okay. So y of z we need to find out. The question is y of n. So finally we'll get log z plus 1 by 2. Always remember that when there is 1 by n, there is possibility to get an answer in terms of log. So y of z is equal to log z plus 1 by 2. A similar question they can ask in 1 by n square also, but this is a very important question. Always remember, when there is 1 by n, you need to apply differentiation property in a different manner. Okay, you need to define a new signal which is multiplied by n, so we will get the normal signal, and now we need to apply the normal procedure. Okay.